Hi, I'm Santosh. Today I'm going to explain about memory management in Spark. Before diving into the memory management, let's see how Spark process data. Let's say we have 1 TB of data, 1 TB is equal to 1024 GB and the target partition size is 128 MB. By dividing it, we'll get approximately 8000 partitions. Executor has cores, both memory and cores. So each core can run one task at a time. When you have 4 cores, you can run 4 tasks at a time. Parallel task is equal to number of executors into cores per executor, which means you have 5 executor, 4 cores per executor. So you have totally 20 cores. So 20 tasks you can run parallelly. So the approximately 8000 partitions divided by this 20 cores, you will get total 410 waves, which is how many rounds Spark process the task. Spark is built using Java. So the internal process, when you process some data, internally the objects created are Java objects. So the Spark memory is managed by Java virtual machine. The JVM heap is a memory. On heap memory is inside JVM heap. It is used when Spark stores data and process data. It is managed by garbage collector. What is garbage collector? When we process some data, it creates some Java objects internally. When we don't use some objects, it will clear the old objects, unused objects. That is a work of garbage collector. Let's say our heap has 1024, which is 1024 MB. In that 300 MB is for reserved memory. What is in the reserved memory? Reserved memory is memory which is allocated for internal usage and metadata purposes. Remaining 724 MB is the actual usable memory. That usable memory is split into 60-40 percentage. The 60 percentage is default and can be increased, which is Spark memory, and remaining percentage is user memory. User memory is basically for stuffs that are not managed by Spark. For user created objects like user defined functions, temporary variables, etc. And this Spark memory is further divided into storage and execution 50-50. But it's not fixed, it's shared dynamically. As you can see here, execution memory can borrow from storage if it needs, but storage cannot evict the execution. So it clearly states that the execution memory has the priority. You can check the calculations here and then we'll see what is meant by executor memory overhead. So overhead memory is located outside the JVM heap. It's more like an extra memory to handle Python processes, native libraries and JVM internals. It also has off-heap memory. What is meant by off-heap memory? Off-heap memory is a memory located outside the JVM heap. It's also used by Spark for data processing and storage, but it's not managed by JVM's garbage collector because it mainly stores in binary format. So you don't need garbage collector. Off heap should be less than or equal to overhead memory space. What is meant by tungsten? Tungsten change how Spark stores the data. So like before tungsten, there will be Java Scala objects created, which will be heavy, more memory. Often garbage collector needs to run to clear that. But binary format is unsafe row format, which is very compact, faster, and less garbage collection needed. You need to understand memory is fast. So the data stored in memory is in a deserialized like in Java Scala objects or in binary form. But data that's stored in disk is in serialized format, very compact but slower to access. we need to understand two things: memory only and memory and disk. So when you catch a data frame like df.catch, when you catch it, it will defaultly mean memory and disk. Let's say example, your memory can hold up to 100 MB, but your catched data frame is 120 MB. So the remaining 20 MB will get spilled to the disk. So no crash will occur, it will be safe. But when you configure memory only, there's no space for uh, the whole data frame to be fit in the memory, so it causes out of memory error, or it can lead to removal of old catch blocks. So we need to recompute it, so it's waste of resources. Spark stores catch data in the memory. If the memory becomes full, it either evicts the old data or moves the data to disk, which means spills the data to disk. It is called a storage spill. During executions, it happen, like for example, when you are performing a join or shuffle operations, if a task needs more memory than available, so it spills the intermediate data to the disk. So it's called as execution spill. Least recently used algorithm is used here to evict the old cached blocks. I hope I've explained Spark memory management clearly. Thank you.